Hello. So I'm going to be doing another showcase today, and this one is of Tatooine Podracing by Newman. This is part of his ongoing series where every Tuesday he does another Tatooine puzzle that he posts to, he doesn't even post it to the archive, he posts it to the Sudoku recommendations channel on the Discord. And the reason he does that is these are often very unfair. So if you would like to, there is a link in the description if you'd like to try it. It's just a classic Sudoku. It could be fun to struggle on it for a little bit, see what you're able to do on it. But don't feel bad if you aren't able to find a clean solve path, because these are more works of art in terms of complex classic strategy rather than something that's fair for a human to solve. But this one in particular, I thought would be really cool to show off some classic techniques, some that you've seen, some that you may not have seen. And if you like this, I'm thinking about doing a series on these extremely difficult classic Sudokus where I do a showcase, I don't know, maybe once a week. And you can just to show off the cool things that people are doing in the classic Sudoku realm, because mostly we see variants, and there are some very, very cool variants, but I think that there's still a lot of really open space and new tech that's coming even to classic Sudoku, despite how old it is. And I think it's cool to give that its own sort of spotlight. And these aren't really appropriate for my streams because there's no way I'd be able to do these live. So again, in the comments, let me know how you think, or what you think about this style of video, if you enjoy these classics, even if you just watch the cool solve path. And again, go ahead and give it a try if you'd like to, see how far you can get, and then watch the video to see the really cool solve path. So I'm going to get started, and as with most or all, pretty much all of Philip's Tatooine style Sudokus, it's going to start with a bunch of swordfishes or jellyfishes or fishes in general. And I'm not going to do that. I'm going to show an alternate way to sort of approach these many fish puzzles using set. And it's a really cool shortcut, and it's also kind of a hint on how these get set. So the Tatooine style is basically when we have these circular sort of setting of the givens. So you've got kind of this circle here. Maybe I'll highlight it just for now. I can highlight this circle here, and then there's sort of these weird distorted circles down here as well. And if you look at Philip's different Tatooine puzzles that he's posted, there's usually like these two circles with different kinds of givens on them, and then there's a weird land mass underneath that changes depending on the puzzle, and that's what really changes the solve path on these. But this general way of setting is done on purpose because it causes a bunch of fish at the very start of the puzzle. So let's take a closer look at this. If we look at here, you can see we actually have a block of 3x3 givens. And then we also have, if I highlight these as well, actually I probably should have before, we also have this block of 3x3 givens. And this is what kind of creates the swordfishes. And instead of thinking of it as swordfishes, what we can do is we can think of it as a set. So you can see that I've highlighted kind of these ones that line up and these ones that line up. And what we can do is we can use that to create a set. So let me get rid of the greens, and I'm going to take these 3 rows and I'm going to highlight those green, and then I'm going to take these 3 columns and I'm going to highlight those purple. So you can see that we've got our circle represented here. And you can see that this sort of 3x3 block of givens is entirely in one set, and this 3x3 block of givens is entirely in the second set, the purple set. And if you know anything about set, I'm going to start from the beginning just in case you don't know anything about set. So I apologize if I'm re-explaining what you already know. But what I've done here is the greens are 3 rows. So the greens are 3 sets of 1 to 9. We know exactly what goes in those rows. It's 1 to 9 3 times. So we have 3 1s, 3 2s, 3 3s, etc., all the way up to 3 9s. The purple is the same. The purple is 3 columns. So we have 3 sets of 1 to 9 in the purples. So right now, the greens and the purples both have 3 sets of 1 to 9. So they have exactly the same digits in them. Now, if you look, there are 9 cells here, these 9, that are in both green and purple. So whatever digit I put in here, let's say, I'll put an 8, right? If this in the final puzzle was an 8, then if I were to remove this cell from both purple and green, then we know that we were removing an 8 from both. And so now purple and green are still the same as each other. They're both the digits 1 to 9 3 times, except 8 is removed from both. So they're still exactly the same as each other. And so I can do the same, and obviously we don't know if it's going to be an 8, but whatever was in here was removed from both. So I can do that for all the rest of these 8. And I can say, okay, I can remove those, and this property still holds. That green has exactly the same digits as purple. And whenever I do this, I like to do a little bit of cleanup just to keep things a little bit sane, which is if I see a common digit common given between purple and green, then I can remove it from both. So in this case here, I could choose any of these purple 4s, but these are the closest together, so might as well use that. And I'm going to remove a 4 from green, and so then I can remove a 4 from purple, and this property still holds. Green has exactly the same digits as purple. So now let's look a little bit more closely about what these digits actually are. Well, in green, I have 1, 2, 3, and 8. Those are the only digits I have in green. 1, 2, 3, and 8. Remember that. In purple, I have 4, 5, 6, 7, and 9. So if you notice, especially because I removed those 2 4s to start with, that's one of the reasons I did it, there's no overlap between those givens. The green has 1, 2, 3, and 8, and the purple has 4, 5, 6, and 9. And that accounts for all the digits. So green has 1, 2, 3. Purple has 4. Let's highlight those ones as well. Purple has 5. Purple has 6. Purple has 7. Green has 8. And purple has 9. So all the digits are accounted for here, but none of them overlap. So we can look a bit more carefully. We can see, okay, well, let's count. Let's start with the greens. So the greens have 1, 2, 3, and 8. Now, how many do they have? Well, it's 3 1s, a 2, 2 3s, and 2 8s. So for a total of 8 givens in the green. Now, how many open spaces do we have in the purple? We have 3 here, we have 3 here, and 2 here. That's 8 open spaces. And so we know that there's none of the givens account for any of those 1, 2, 3, 8s, and there's only 8 spaces to put them. And so those must go in those spaces. Like if I were to put anything other than 1, 2, 3, 8 in any of these open spaces, then purple and green couldn't have the exact same digits as each other because I couldn't have enough 1, 2s, 3s, and 8s in the purple to count for all the 1, 2s, 3s, and 8s that we know are in the greens. So I'm going to highlight all these purples. And the first thing I'm going to do is I'm just going to put 1, 2, 3, 8 in all of them. But we're not going to stop there, obviously. Let's clean it up a little bit. This can't be 1 because of the box. This can't be 2. This can't be 3. This can't be 3. In fact, none of this row can be 3. This can't be... Actually, this could be any of them. And this can't be 8. So we could stop there, and we notice, actually, we got a... actually, this can't be 8. Sorry, let's clean that up properly. We got a 1, 2, 8 triple in this row, so that's already super good. But we're not going to stop there, because what we're going to do is we're going to take a closer look at how many of each of these we have. So first, we have 3 1s. So if you look at our purples, we only have 3 rows of blank cells in our purples. And so how many 1s could we have in those 3 rows? It's not a trick question. We can have 3 1s. And so we must have 3 1s in each of those rows. And so that means that within each of these rows, we must have a 1 in each of them in the purples which means none of these white cells have a 1. And we probably would have found a swordfish on 1s that would have been equivalent to that, but this just gets it automatically, and we're getting a bunch all at once, right? Like we got this 1 to 8 triple, for example, so we already knew that 1 couldn't be in these. But what I'm going to do is I'm going to signify that, which I'm going to go a little bit against the grain here, and I'm going to corner mark 1s where 1 must go in these rows. That way we can remember that. 2, there's only 1 2, but we know it has to be in this triple. I can't get away with not putting a 2 in this 1 2 8 triple. So that 2 is accounted for, which means we're not allowed to have any more 2s. So I can actually remove 2 from all of those. 3s, we have 2 3s. Now if you remember, the reason we got this 1 2 8 is because there's a 3 already in this row. So how many rows do we actually have to accommodate 3s? Well, it's just 2 rows left. So each of these rows 1 and 9, must have a 3 in it. So I'm just going to signify that by corner marking 3s here. Now, if you remember from corner marking within a box, if you end up with 2 spaces with 2 corner marks only in those 2 spaces, then that would have been a hidden pair in the box. Well, it's exactly the same. We're just doing it for rows. So we've actually discovered a hidden 1 3 pair in this row. And the way you can think about that is if this cell were an 8, this row would have to contribute a 1 and a 3 in the purples and would only have 1 cell left for that. So this would have to be both a 1 and a 3. So however you want to think about that, this cell cannot be 8 because if it were, we wouldn't have enough open cells in this row to account for the 1 and 3. So now that this is a 1 3 pair, I can get rid of that corner mark. And this is a 1 3 8 triple, so I can get rid of those corner marks as well. So now we've actually gotten 3 triples on these rows. And we're only half done. We still need to do the columns. So if you remember, we have 4, 5, 6, 7, 9 in these purples. And how many are there? Well, there's 3, 6, 9 of them. And how many open spaces do we have in the greens? Well, we have 3, 6, 9 in the greens. And so we have the exact same situation where 4, 5, 6, 7, and 9 must be in these green cells. So I'm just going to start by typing 4, 5, 6, 7, 9 into these, and we're gonna clean it up like we did before. This column has a given 7, so we can get rid of that 7 there. This can't be 4. This can't be 5. This can't be 6. We already got rid of 7 there. This can't be 6. And I'm just looking at the box because we already accounted for the columns. So this one couldn't be 4. This can't be 6. This can't be 4. This can't be 7. 4, 5, 6, 9. Yeah, I think that does it. I apologize if I miss anything. So now what we can do is we can do the same analysis of our givens. So 4s, we have 2 4s in the purple, and we have 3 columns to put them in. So we don't actually know where the 4 goes yet. All we know is that there's going to be 2 of them out of these 3 columns. We'll have them in greens. So that's not that useful. The 5 we only have 1 of. Again, not that useful. We haven't isolated any kind of triples here, so we can't use that method. But we do have 3 6s. And so we need a 6 in each column. So what I can do is I can actually mark these. I guess not this one. And I can corner mark a 6 there. And that'll remind us that 6 can't go in any of the white cells outside of here. And then 7, we have 2 7s. But if you remember, there was a 7 already in this column. So we only have 2 columns to contribute 7s. And so we can actually corner mark 7s in these 5 cells. And so that's what we get from those sets. And it's actually a lot. And this accounts for every swordfish that you would have found from the start. At least that the important ones. I don't know if there's more. But hold on, this 4 here, let's get rid of that 4. Just make sure I've cleaned up all of these properly. 4 can't go here either because of this given 4. So I think that should account for everything we needed. One thing to note is that I suppose we could do this. There are 2 4s in the purples, and this row had a given 4. So we can say that these cells must have a 4 in it. There's a 4 in one of these two. There's a 4 in one of these two. And also in this column, I'm not sure if we can say in this column, actually. No, we can't, because there could be a 4 here and a 4 here, and then there could be a different 4 given for this column. So we can't say that. So that should actually do it for this set. So I'm gonna clear out the highlighting there to keep things clean. The next thing that I'm gonna show is a Y-wing. So you can see it's already marked here. So we have this Y-wing here. I'll mark this one orange and this one red. So this 1-8 is the pivot. This is just a standard Y-wing. If this cell is 1, this blue cell is 3. If the orange cell is 8, this blue cell is 3. So one of these, at least one of these two is a 3. Both of them see this red cell. So this red cell cannot be 3. So it is a 1. That actually turns around and makes this one a 3. So we can unhighlight these. And now if we follow the ones, this can't be 1 anymore. This could never have been 1. If we follow the ones around, there's a 1 in one of these two. There's these ones see in these 3 ones. So there's a 1 here. These ones see over. There's a 1 here. That eliminates 1 here. And there's a 1 here. These ones look in. That places a 1 here, and that gives us this one. And that actually finishes off all of our 1s. So we don't have to worry about 1s anymore. The next thing I'm going to show, there's actually a lot of ways to move forward from here, and none of them are particularly nice. I definitely played around with this a lot, and Philip actually showed me a really cool way to move forward, which is what convinced me to make this video. He wasn't trying to convince me to make the video, but I wanted to. I guess before we show that, I think you guys are probably yelling about this, so I will do it. It's really not super necessary for what we're going to show, but 6s look in here, which limits 6 to these 2 cells, and 7s do the exact same thing. So we kind of have a 6-7 here and a 6-7 here, looking at this cross here. And so this is a 6-7 hidden pair, so this can only be 6-7 as well as this one. Remember, our corner marks here are not for the boxes, they are for the columns, so let's remember that. So the question I'm going to ask is, first, where can 4s go in this row? If you look, they can only go in these 2 cells. This 4 removes it from these 3. That's a given. This 4 removes it from here, and this 4 removes it from here. So 4, I'm going to mark that green, can only be in one of these 2. And then in this column, where can 4 go? Well, it can go here. Let's mark that green. 4 can't go here. Can't go here because this 4, that was this 4 here. And this 4 blocks it out here. So 4 can only go here. So this is what's called a 2-string kite. If you haven't heard of that before, the way it works is pretty easy to understand. Basically, if you can understand the X-wing, the 2-string kite might actually be easier to understand. So there must be a 4 in this column, and there must be a 4 in this row. Now, both this row and this column are limited where 4 can go to 2 spaces. 2 spaces in this column, 2 spaces in this row. And one of each from each of those share the same box. So I can at most put 1 4 in this box, and the other one then gets shunted out to one of these outer cells. So we could have it in both of these outer cells, and we could have it in one of the outer cells and one of the inner cells, but I can't have it in both the inner cells, right? So one of these 2 is a 4. And normally you would sort of stop there and go, well, what do both of these see? Since I know at least one of them's a 4, well, both of them see this cell and both of them see this cell. So we would eliminate 4s from those cells. Now that's obviously not too useful. They're already givens. We know they're not 4s. However, let's now look at this row and ask where 7s can go. Well, this 7 sees these 3. 7 could go here. remember 7 can't go here because our set, that's why I corner marked the 7s here. 7 cannot go in this cell. And 7 can't go in this cell because of this 7. So 7 is actually limited to, and obviously not in the given, 7's limited to these 2 cells. So I'll make that purple. And then in this column here, where can 7 go? Well, we can actually just look at our corner marks and say, our set told us that only these 2 cells can have a 7. Because this one sees the 7 here. It was the set where it was these 3 in this column. So we have another 2-string kite. And again, in this column, 7's limited to 2 places. In this row, 7's limited to 2 places. So how can we put 7's into these 4 cells? We know there must be 2 7's in these 4 cells. And so we can't put both of them in this box. And so one of them does get shunted out to one of these outer cells. So this 2-string kite is shunting a 4 into one of these 2 cells, and this 2-string kite is pushing a 7 into one of these 2 cells, and they're sort of fighting each other. So I can't put 2 4s or 2 7's into those outer cells because that would break the other 2-string kite, and I can't put none in those 2 cells because each 2-string kite is saying at least one needs to be in. So if both are saying at least one, both are that means that there's exactly one of each. So I can actually mark this as a 4 7, and I can remove 5 and 9 from here. And these are actually a 4 7 pair, which we can remember. It's not just that it's a 4 7 candidate. They basically see each other through this 2-string kite overlap, which I think is really, really cool. I've never seen that. I'm sure there's some out there going, oh, I've seen that before, but this was new. Because we're not using the 2-string kite in the way it's normally used in eliminating from these 2 cells. Instead, we're actually using the overlap as a direct consequence. Now, the other direct consequence of this, which may not have been immediately obvious, it certainly wasn't to me, is because only one of these 2 can be a 7 and only one of these 2 can be 4, that means one of these 2 is definitely a 7 and one of these 2 is definitely a 4. Because remember, we still need, and here this is 6 7 pairs, so that's not that important. But out of these 4 cells, we must place 2 4s, and only one of them can go in these outer cells, so the other one must be in one of these 2. So I can actually mark one of these 2 as a 4, which it's a little bit confusing because these are corner marks for the box, whereas this 6 and 7 are corner marks for the columns. But hopefully you'll bear with me there. And so if we look at this cell now, what can this cell be? It sees a 1, a 2. It sees a 3 from the 3 8 pair. It sees a 4 now, because 4 must be in one of these 2, which is not this one. It sees a 5. It sees a 6, because we have these 6 corner marks. These 2 are corner marked 6. So let's just use that one as a placeholder for that. So it sees that 6. It also sees a 7. Let's use that as a placeholder. Again, our set eliminated both 6 and 7 from this cell. And it sees an 8 in this 3 8 pair. So it's a naked single. This is a naked single 9. So to go over that again, it's a naked single 9 because of the 1, 2, and 5 in the box. The 3 8 pair that we got from the set, as well as the 6 and 7 from the columns that we got from the set, and the 8 also from the pair. So I think that's really cool. And that eliminates 9 from these. And if you look, now this 9 sees down, this 9 sees up. That places a 9 here. And then this 9 sees over here that we have this 6 7 hidden, and this 1 2 8 that we got from the set, which actually places a 9 here. We might as well corner mark 9s in one of these 2. These 2 9s see over here, we can corner mark a 9 into one of these 2. So now if we look at 3s, we have these 2 3s looking in. That places a 3 here. And now where does 2 go in the box? We have this 2 8 pair looking here. This can't be a 2. So We place the 2 here. Remember, this couldn't be a 2 because it was part of our set. And then this is now down to 4, 5, or 7, but it can't be 7 because, again, our set must have the 7 in it. And then for this row, we only need 3 values left. We need a 2, a 5, and an 8. This one can't be 8. In this column here, what do we need left? We have 1, 2, we need 3, we have 4, 5, 6, we need 7 and 8. This one can't be 8. This one can't be 3. In this column here, we have a 1, we need 2, we have 3, 4, we need 5, and we need 8. Again, this one can't be 8. These 4s, look over here, places a 4 in one of these 2. So now for the rest of this row here, what do we need in this box? So we have a 1, we have a 2 in the 2, 8 pair, we have a 3, we need 4, 5, 6, 7. We have an 8 in the 2, 8 pair, and we need 9. Remember, this one can't be 6 because we have the 6's corner marked for this column. And then the 7 also is eliminated because of this given 7 here. And so now if you look, we actually have a 4, 5, 6, 9 quadruple in this column out of nowhere. And so these 3 cells, we have a 1, we need a 2, 3, we have 4, 5, 6, 7, 9, so we also need an 8. And if you look, we have this 3, 8 pair here already, so actually this is a 2. Make it single 2 somehow. And we have a 3, 8 pair remaining here. This cell here, what does it see? It sees a 1, sees a 2, sees a 3, 4, doesn't see 5, but it sees 6 and 7, 8, and 9. So it is a naked single 5. These cannot be 5 anymore. And what does this cell see? Well, it sees a 1, 2, 3, 4, 5, 6, 7, sees an 8 in this 3, 8 pair that we just uncovered, and so the only value left for it is a 9. And this 5 we placed here earlier, that eliminates a 5 from here. That makes a 4, 7 pair, meaning that this is a hidden single 5 here. So this can no longer be 5. So now with this 3, 8 pair, we should, this can't be a 9. And we should be able to fill the rest of these 2. So we need 5, 6, and 7. You can see that a 5 and a 6 already see this one, so that's a 7. And for the rest of this row, we have a 1. We need a 2, 3. We have 4, 5, 6, 7. We need 8 and 9. You can see that we already have a 2, 9 in the box, and an 8 in the column. So this is a 3, this is an 8, this is a 3, 8, 7, 4. Remember that this is a pair, so that's a 7. This is 6 and 7. These 2 can't be 3 or 8, so that's a 2, 9 pair. That's not a 2. Never could have been. And now you can see this 8 sees across here, so this is the only place for 8 in the box. This can no longer be a 7, so this would be a 4, 6 pair for the box. And over here we have a pair as well. We need a 2. We have a 3, 4. Oh, sorry, we don't need a 2. We have a 2 in the 2, 9. We have 3, 4. We need 5 and 7. So we know which way that goes. That's 5 here, 7 here. 5 C's down to here. 5 C's over here to 6 and 4. That's a 6. That's a 7, 4. We now know in this column, this is the only place for a 6. That's our last corner mark for the column, so we can immediately put a 6 there. And then looks like 2, 8, and 9 are the remaining for the column. That places this 4 here. This can't be a 9, so this is a 2 or 8. That leaves here for 9. This is 2, 5. That 5 C's down. That leaves just here for 5. we have a 6 here, so this is no longer 6. That leaves a 4-9 pair, so this is the 6. That leaves here for 5, 9. You can see it's just collapsing from here. This is 3 or 7, can't be 7. So, oops, it's not 3 or 7. Oh, there's 7 already in the row, so that's a 3. We need a 2, that's an 8, 2. This 4 sees up, that's 9 and 4. That's a 3. 1, 2, 3, 4. We need 5 and 8. It's not resolved yet. Here, for the column, we have 1, 2, 3, 4. We need a 5 and a 6. And we have a 6 here. So this is 5, this is 6, this is 8, this is 5. Here we need a 2 and an 8, so that goes this way. That's a 2. And finally, we have a 9 here. Oh, I'm not quite done. This 2 sees up, that's 8 and 2. And now we are done. All right, so I hope you enjoyed that solve. Sorry about the end there. I didn't have that planned out. But as you can see, that once we've actually found this 2-string kite here, it was pretty much hidden and naked singles from there. So I thought that was pretty neat. If you struggle with the puzzle without finding this and the cool effect of it removing a 4 from this cell, along with, of course, all the gazillion swordfishes, or if you use the set, that's awesome, from using the set, then you don't get anywhere near having a naked single 9 there. So I thought that was pretty awesome. And that naked single 9 just blows the whole puzzle open. So I hope you enjoyed that. Do let me know if you enjoy this kind of showcase where I show off a cool technique within classic Sudoku. I'm happy to make more of these if you guys enjoy it. And if you do enjoy my videos and you haven't already, please make sure to subscribe. And of course, I do stream twice a week now. I stream on Thursday nights and on Saturday mornings, which for people in Europe, that's actually very early on your Fridays, so you probably can't make that one. And Saturday evenings for you. So please feel free to stop by. I do live solves and collaborative solves of Sudoku variants mostly, and we have a lot of fun with that. So until next time, thanks for watching.